What if the most solid things around you are not really solid at all? What if the chair beneath your body, the phone in your hand, even the bones inside your chest are not made of stuff in the way you were taught to believe, but are closer to instructions being followed, rules being executed, information being temporarily arranged into a convincing shape? What if reality is not built from matter, but from messages? For most of human history, the world felt heavy, reliable, unquestionable. Stone was stone, water was water. The sky was simply above us. You could trust your senses because survival depended on them. If something looked solid, it usually was. But slowly, quietly, that certainty began to erode, not through philosophy first, but through physics, through experiments that behaved like riddles, through equations that refused to describe things and instead described relationships, probabilities, limits, through discoveries that made scientists pause and whisper, "That's strange," and then whisper it again for 100 years. At the smallest scales we can observe, matter stops behaving like matter. Particles do not sit politely in one place. They smear themselves across possibilities. They act like waves until you look at them, and then, only then, decide to become particles. And even that decision feels temporary, conditional, almost reluctant. It is as if reality waits, as if it holds its breath, as if it asks a question before answering one. You might think this is just a technical detail, a quirk of tiny things that doesn't matter to everyday life. But cracks never stay small, they spread. And the deeper we look, the more the universe begins to resemble something eerily familiar. Not a machine, not a substance, but a system. A system that processes information. Consider this. Physics no longer tells us what things are. It tells us what can be known, what can be measured, what can be transmitted, what can be conserved. The most sacred laws of modern physics, conservation laws, are not really about matter at all. They are about information. You cannot destroy it. You cannot create it from nothing. You can only transform it, rearrange it, encode it differently. This is not poetic metaphor. This is mathematics speaking in a quiet, unsettling voice. When a particle disappears in one place and appears in another, what truly moved? When two particles become entangled, sharing a state across distance, what exactly is being shared? Not mass, not energy in the traditional sense. It is information, correlation, rules that bind outcomes together even when space tries to pull them apart. Reality, it seems, does not care as much about objects as it does about states, about configurations, about what is allowed to know what. And suddenly the world feels thinner, less like a pile of bricks, more like a script being read line by line. Think about how you experience reality. You never perceive everything at once. Your brain samples. It filters. It compresses. Out of an overwhelming flood of sensory data, it constructs a usable model, a story you can live inside. Colors are not properties of objects, they are interpretations. Sounds are not things. They are vibrations translated into meaning. Even now is not a single moment, but a stitched-together delay, a buffer where signals arrive at slightly different times and are edited into the illusion of immediacy. You are already living inside an interface. So, what if the universe is doing something similar? What if what we call matter is the interface? Useful, convincing, emotionally persuasive, but not fundamental. What if beneath it lies something colder, simpler, more abstract? Bits instead of bricks. Yes or no instead of solid or empty. A cosmic language that doesn't care how it feels to us, only that it runs consistently. This idea is unsettling because it removes comfort. Matter feels safe. Matter feels ancient. Information feels fragile, editable, copyable, corruptible. Information can be lost, overwritten, distorted, and yet physics insists, again and again, that information is the one thing the universe protects most fiercely. Even black holes, the most violent objects ever discovered, seem unable to destroy it. They can shred stars, bend time, erase entire histories from view, but the information describing what fell in must, somehow, still exist. Encoded, hidden, preserved like a cosmic checksum, ensuring nothing essential is truly lost. Why would the universe care so much about that? Why would reality enforce rules that look suspiciously like error correction? The more we study the foundations of physics, the more limits appear. Not arbitrary ones, but clean, precise boundaries. A maximum speed, a smallest length, a smallest unit of action. These are not the traits of a messy, continuous substance. They are the traits of a system with resolution, with pixels, with bandwidth. Space itself appears quantized, not infinitely smooth. Time ticks in indivisible steps at the smallest scales we can probe, and suddenly the universe starts to feel less like an endless ocean and more like a grid, less like clay and more like code. This does not mean the universe is a computer in the way humans build computers. That analogy is too small, too literal, but it does suggest something deeper. Computation may not be a thing that happens inside the universe. It may be what the universe is. If that is true, then every atom is not a thing but an instruction. Every force is not a push, but a rule. Every event is not an accident, but a lawful update from one state to the next. Reality does not move forward in time. It refreshes. And you, listening to this right now, are not just a body sitting somewhere in space. You are a process. A pattern maintained long enough to ask questions about itself. A temporary coherence in a sea of transformations. This is where the fear creeps in. Because if reality is information, then meaning becomes slippery. Information has no inherent purpose. It does not care. It only follows rules. And yet, here we are, feeling, hoping, suffering, loving, as if those things matter absolutely. How do those two facts coexist? Perhaps the most disturbing thought is not that reality might be coded, but that it might be coded without intention. No author, no watcher, just a self-consistent structure unfolding because it can. A story that tells itself because the rules allow it to continue. Or perhaps the intention is not visible from inside the system. Perhaps asking why is like a character in a novel asking why grammar exists. We are standing at the edge of an idea that feels both illuminating and hollowing. If matter is not fundamental, then the ground beneath our intuitions dissolves. Death becomes less like disappearance and more like deallocation. Birth becomes initialization. Memory becomes storage. Identity becomes continuity of information across time. And suddenly the question shifts. Not, what is the universe made of? But, what does it mean to exist in a universe that behaves like this? This first crack, the suspicion that reality is information, will not close again. Every segment that follows will widen it. We will follow this idea into quantum mechanics, into black holes, into consciousness, into meaning itself. But for now, sit with the discomfort. Let the solid world feel a little less solid. Let the silence between particles feel a little louder. Because if reality is information, then the most important question is no longer what things are, but how they are written. What if reality does not exist in the way you think when no one is looking at it? Not metaphorically, not philosophically, literally. What if the universe withholds its answers until a question is asked? What if existence itself behaves less like a finished painting and more like a scene that only renders when the camera turns toward it? This idea sounds absurd at first, almost childish, like believing the world disappears when you close your eyes. And yet, modern physics keeps circling back to something uncomfortably close to that intuition. Again and again, experiments whisper the same unsettling suggestion. At the deepest level, reality does not fully commit until it is observed. In classical thinking, observation is passive. You look at a thing, and the thing remains what it is. The moon does not care if you watch it. A rock does not change because you measure it. Observation is just information flowing one way, from the world into your senses. But at the quantum scale, this simple picture collapses. Observation becomes invasive. Measurement becomes an event. And looking is no longer neutral. Take a particle, an electron for instance. Before you measure it, physics does not describe it as being in one place or another. Instead, it exists as a spread of possibilities, a cloud of probabilities. Not metaphorically, mathematically. The particle is not hiding its position from you. According to the equations, it does not have one. It occupies many potential states at once. Then you measure it. You ask the universe a precise question. Where are you? And suddenly, the particle answers. It appears in a specific location, as if it has chosen one outcome from many. The wave of possibilities collapses into a single fact. And the unsettling part is this. Physics cannot tell you when that decision was made, only that it happens when information is extracted. It is tempting to imagine that the particle really had a position all along and we just didn't know it. But experiment after experiment rules that out. The behavior changes depending on whether information is available, even if no human ever looks at it. The mere possibility of knowing alters what happens. This is not intuition friendly. It feels wrong because it violates the story we tell ourselves about reality being independent of us. But the universe does not seem interested in protecting our comfort. Consider one of the strangest experiments ever performed. When particles pass through two slits, they create an interference pattern, waves overlapping with waves, as if each particle goes through both slits at once. But if you place a detector to see which slit the particle goes through, the interference vanishes. The particle behaves like a single object again. The mere act of asking which path destroys the wave-like behavior. And here is the truly disturbing part. If you erase that information later, after the particle has already passed through the slits, the interference can return. It is as if reality revises its own history based on what can be known in the present. The universe does not just respond to observation, it responds to information structure. This is not mysticism. This is experimentally verified physics. So we are forced to ask a question that feels dangerous. What counts as an observer? Is it a human mind? A measuring device? A conscious experience? Or is it something colder and more abstract? The moment information becomes irreversibly recorded somewhere in the universe. Physics does not give us a satisfying answer. It only tells us that observation is not about eyeballs. It is about interaction, about entanglement, about when a system becomes correlated with another system in a way that cannot be undone. When information leaks out, reality chooses. This makes the universe feel less like a stage and more like a conversation, a call and response between questions and answers, between potential and fact. And it raises a chilling possibility. Perhaps reality is not fully there all the time. Perhaps it exists in a suspended state, pregnant with outcomes, waiting for constraints to force its hand, waiting for information to flow. Think about how a video game works. The entire world is not rendered at full detail at all times. Only what the player can see is generated. Not because the rest does not exist, but because generating it would be wasteful. The system conserves resources. It calculates only what is required. Now pause. This is only an analogy, but notice how closely it matches what physics describes. A universe where outcomes are not fixed until queried. A universe where limits on information transmission define what can and cannot happen. A universe where reality seems optimized, efficient, almost economical. Does this mean we live in a simulation? That question is premature. It distracts from something deeper and more unsettling. Even if this universe is not simulated by anyone, it still behaves as if it is being computed. And that behavior alone changes how we must think about existence. Because if observation shapes reality, then knowledge is not passive. It is creative. Every measurement is an intervention. Every question is a small act of violence against uncertainty, forcing the universe to pick a side. This reframes the role of consciousness in a quiet but profound way. Not as a magical force that controls reality, but as a participant in an informational exchange. Conscious beings are systems that ask questions. They extract patterns. They reduce uncertainty. And in doing so, they leave marks on the world. You do this constantly without noticing. Every time you look at something, your brain collapses countless ambiguities into a usable narrative. It throws away most of the data and keeps only what matters for survival. You never perceive the full richness of reality. You perceive a compressed version, a story optimized for action. So perhaps the universe and the mind are not opposites. Perhaps they are mirrors operating at different scales. Both take vast possibility spaces and reduce them into something definite. Both turn information into experience. And here the unease deepens. If reality depends on observation to take shape, what did the universe look like before observers existed? Before stars formed eyes? Before matter arranged itself into brains capable of asking questions? Physics offers a cold answer. The universe observed itself. Particles interacted. Fields entangled. Information flowed. Observation does not require awareness, only irreversible correlation. Consciousness is not the trigger, it is a refinement. But this does not fully quiet the discomfort, because even if humans are not special observers, the structure remains. Reality becomes definite only through informational interaction. There is no single absolute version of the world, only states that become real relative to other states. Reality is relational. This means that what happened is not always a simple universal fact. It depends on what information exists, where it exists, and who or what has access to it. The universe does not maintain one master narrative. It maintains consistency locally, through rules that prevent contradictions. But globally, it allows ambiguity to persist until forced to resolve. This is not chaos, it is disciplined uncertainty, and it hints at something radical. Maybe the universe is not built from things, but from questions and answers, from constraints and updates, from what can be known and what must remain hidden. If that is true, then certainty is not the default state of reality. It is the exception, a temporary crystallization in a sea of possibility. You are one of those crystallizations. Your life feels continuous, solid, unquestionable. But beneath that feeling lies a fragile chain of correlations, memories stored in neural patterns, identities maintained through repetition, meanings reinforced through feedback. You persist because information persists, because the pattern holds, and patterns can fail. This is why the idea unsettles us so deeply, because it suggests that existence is not guaranteed by substance, but by structure. Not by being, but by coherence, and coherence can break. In the next segment, we will follow this idea further down, to a place where matter itself dissolves into pure description, where the smallest units of reality are not particles, but bits, where physics begins to sound less like chemistry and more like language. What if atoms were never the foundation we believe them to be? What if everything you were taught to think of as basic, particles, forces, fields, turns out to be a surface layer, a readable output of something deeper and far less tangible? What if the true bedrock of reality is not matter at all, but information quietly rearranging itself according to rules we are only beginning to glimpse? Physics did not arrive at this idea through imagination. It arrived there reluctantly, dragged by equations that refused to cooperate with intuition. Again and again, when scientists tried to describe what the universe is made of, the language of substance failed them. What survived was something stranger: relations, numbers, limits, transformations. Not things, but descriptions of how things could change. At the deepest level we can probe, particles lose their individuality. They stop being little marbles moving through space. Identical particles are not merely similar. They are indistinguishable in principle. Swap 2 electrons anywhere in the universe, and nothing about reality changes. There is no hidden label, no secret serial number. Physics cannot tell them apart because there is nothing to tell apart. Identity dissolves. This alone should unsettle you, because objects are supposed to be defined by what they are. Yet here we find entities defined only by how they behave, by the information they carry, by the rules they obey. When physicists write down the laws of nature, they do not describe material essence. They write equations that track how information flows from one state to another: momentum, energy, charge. These are bookkeeping tools, ways of accounting for conserved quantities. And conservation, once again, is not about preserving matter. It is about preserving information through transformation. The universe, it seems, is less interested in what exists than in what remains consistent. This shift becomes impossible to ignore when you reach the frontier where quantum mechanics and gravity collide. In these extreme conditions, familiar concepts collapse. Space and time lose their smoothness. Geometry itself becomes uncertain, and yet one principle keeps reasserting itself, almost stubbornly. Information must be preserved. Even when matter is crushed beyond recognition, even when space-time twists into forms we can barely describe, the informational content refuses to vanish. It may be scrambled, hidden, encoded in correlations spread across the universe, but it cannot be destroyed. Why? Why would reality enforce this rule so absolutely, even at the cost of breaking our understanding of space and time? Some physicists began to suspect that they were asking the wrong question. Perhaps information is not something the universe protects. Perhaps it is something the universe is made of. This idea was once considered philosophical indulgence. Today it sits quietly at the center of serious theoretical work. The phrase "it from bit," the notion that physical reality arises from informational yes or no questions, was once a provocative slogan. Now it reads more like a warning we ignored for too long. When you zoom in far enough, matter dissolves into probability distributions. When you zoom out far enough, space-time dissolves into geometry shaped by equations. In between, what remains stable is structure, pattern, code-like regularity. The laws of physics themselves appear compressible. The entire observable universe can be described using a surprisingly small set of equations. This is not what you would expect from a world built out of arbitrary substance. It is exactly what you would expect from a system governed by underlying rules that repeat. Compression is a signature of information. A random collection of facts cannot be compressed, but a lawful system can. The more lawful it is, the shorter the description required to generate it. The universe, astonishingly, seems to favor elegance. Simple rules give rise to unfathomable complexity, like a fractal unfolding from a short algorithm. This does not feel accidental. Consider how much of reality is defined not by presence, but by constraint. The speed of light is not just how fast things go, it is how fast information can travel. The uncertainty principle is not about measurement error, it is about limits on how much information can exist simultaneously about complementary properties. Even space itself appears to have a smallest unit, a pixel beyond which information cannot be stored more finely. Reality has resolution, and resolution implies encoding. At this point, the language of matter begins to feel misleading. What we call particles are excitations of fields. What we call fields are defined by equations. What we call equations are relationships between variables. And variables are, at their core, symbols standing in for values. You can follow this chain down as far as you like. It never ends in stuff. It ends in description. This realization produces a quiet vertigo. Because if the universe is built from information, then physical is no longer the opposite of abstract. The abstract becomes the foundation. The physical becomes the manifestation. And suddenly the world you inhabit feels less like a place and more like a process that updates, a process that enforces rules, a process that does not care about your expectations, only about consistency. This reframing forces us to reconsider some of our deepest assumptions. For example, causality. We think of causes as forces pushing objects around. But in an informational universe, causality is constraint propagation. One state limits the possible next states. Cause and effect are not pushes. They are restrictions on what can follow. Time itself begins to look different. Instead of a river flowing forward, it resembles a sequence of computational steps. One configuration gives rise to another according to fixed rules. The flow is not something happening in time, it is time. This helps explain something deeply unsettling: why the universe appears to care more about mathematical consistency than about human intuition. Why it allows outcomes that feel impossible as long as they obey the rules. Why it denies outcomes that feel reasonable if they violate informational limits. The universe does not ask if something makes sense to us. It asks only if it is allowed. And this is where the existential weight begins to press down. Because humans are meaning-making creatures, we look for purpose, narrative, intention. But information systems do not run on purpose. They run on rules. So, where does that leave us? If you are a pattern of information, a configuration that persists long enough to reflect on itself, then your existence is not guaranteed by mass or permanence. It is guaranteed only as long as the pattern holds, as long as the information remains coherent, as long as the process continues. This makes life feel fragile in a new way, not because matter decays, but because information can degrade. It can be corrupted. It can lose fidelity. Memory already teaches us this. Identity already hints at it. Trauma already demonstrates how patterns can become trapped in loops, repeating even when the original cause is gone. You are not a thing. You are a story the universe is telling about itself. Using matter as ink and time as grammar, and stories can end. But they can also be transformed, copied, continued in altered form. If information is fundamental, then death is not annihilation in the classical sense. It is loss of access, loss of coherence, a pattern dissolving back into the larger informational sea, not erased, but no longer readable in the same way. This is not comfort. It is not despair. It is something colder and more honest. It suggests that meaning does not come from being permanent. It comes from being coherent while you are here. from participating in the unfolding, from influencing which questions get asked, which information gets extracted, which patterns are reinforced. Because in an informational universe, attention matters, observation matters, interaction matters. These are not philosophical claims, they are physical ones. And now, the thread tightens. Because if information is the true substance of reality, then the most extreme environments in the universe should reveal how it is stored, protected, and transformed. There is one place where these questions become unavoidable, a place where space ends, time fractures, and information faces its greatest test. In the next segment, we will descend into that place, into the heart of black holes, where reality is compressed to its limits, and the universe is forced to reveal what it values most. Why does the universe feel so efficient? Why does it seem to achieve everything it does with so little instruction? Why do a handful of equations govern galaxies, stars, atoms, and light itself, as if reality is running on a minimalist operating system? If the universe were built from raw substance alone, you would expect mess, excess detail, arbitrary complexity, endless special cases. But instead, what we see is restraint, compression, elegance so severe it almost feels intentional. This is where the story takes a darker turn, because compression is not a property of matter, it is a property of information. In information theory, compression means something precise, reducing a message to its shortest possible description without losing essential content. Random noise cannot be compressed, but structured systems can. The more lawful the system, the shorter the code needed to describe it. And the universe, disturbingly, appears to be highly compressible. Everything we know, from the orbit of planets to the fusion inside stars to the vibrations of quantum fields, can be derived from a small set of rules written in a language of mathematics. Entire galaxies unfold from equations that fit on a single page. The behavior of all known particles follows patterns simple enough to teach, yet rich enough to generate everything you have ever seen. This is not normal. If reality were brute matter colliding blindly, complexity would pile up. Laws would multiply. Exceptions would accumulate. Instead, physics keeps doing the opposite. It keeps simplifying, unifying, reducing, as if the universe is trying to tell us something by how little it needs to exist. Even stranger, the closer we look, the more reality seems to reuse itself. The same mathematical structures appear again and again at different scales. Waves behave like particles. Particles behave like waves. Fields echo geometries. Geometries behave like thermodynamic systems. Thermodynamics starts to look like statistics. Statistics looks like information theory. The universe does not just repeat patterns. It rhymes with itself. This is where the idea of procedural generation quietly enters physics. Not as a metaphor borrowed from technology, but as a description of how simple rules can produce staggering complexity when iterated. Snowflakes, coastlines, clouds, all emerge from basic constraints applied repeatedly. You do not need to specify every detail in advance. You only need the rule. Reality seems to work the same way. Instead of storing every detail of the universe explicitly, it may only store the rules for generating detail when needed. The structure is implicit. The outcome is dynamic. And this brings us to an unsettling realization. The universe does not appear to carry unnecessary information. It does not remember more than it must. In physics, this shows up as limits. Limits everywhere. Limits that feel suspiciously like resource constraints. There is a maximum speed at which information can travel, a maximum density of information that can be stored in a region of space, a minimum length below which the concept of distance stops making sense, a minimum unit of time below which before and after blur into ambiguity. These are not philosophical boundaries. They are measurable, enforced, absolute. And boundaries like these are not the hallmarks of infinite substance. They are the hallmarks of a system with resolution. Imagine zooming into reality the way you zoom into a digital image. At first, everything looks smooth, continuous, but keep zooming, and eventually pixels appear, push further, and the image breaks apart entirely. Not because the image is fake, but because there is nothing more to see. Physics suggests we are approaching that limit. Space itself may be made of discrete units, stitched together by rules rather than filled with continuous fabric. Time may advance in indivisible steps, not as a flowing river, but as a ticking clock. And what we experience as smooth motion may be an illusion created by rapid updates, just as film appears continuous despite being a sequence of frames. If this is true, then the universe is not infinitely detailed, it is optimized. And optimization always implies trade-offs, which raises a disturbing question. What does the universe choose not to compute? What details are left unresolved until forced into existence by interaction? What remains undefined until information must be produced? We already know the answer at the quantum level. Many properties simply do not exist until measured. They are not hidden. They are undefined. The universe does not bother to specify them until it must. This is not laziness, it is efficiency. And efficiency is not a property of matter. It is a property of algorithms. This is where the language of code stops being a metaphor and starts becoming unavoidable. Not code written in lines and symbols, but code as constraint. Code as lawful transformation. Code is the shortest description of what can happen next. The laws of physics behave like functions. You input a state, they output the next possible states. Probability distributions act like decision trees. Constants act like hard-coded parameters. Conservation laws act like error-checking routines that prevent contradictions. Reality enforces consistency the way software enforces logic. But unlike software, there is no visible programmer, no interface, no comments explaining why things are the way they are. Just rules. Cold, elegant, absolute. This creates a strange emotional tension, because we live inside a system that feels personal, filled with beauty, suffering, joy, meaning, yet appears to be driven by impersonal structure. The universe does not bend to our values. It does not slow down for our grief. It does not speed up for our hope. It runs. And yet, within that running, something extraordinary happens. Complexity emerges. Self-reference appears. Systems arise that can model themselves, that can ask questions about the rules they obey, that can suffer because they understand impermanence. You are one of those systems. Your brain is a compression engine. It takes the overwhelming richness of reality and reduces it to something navigable. You do not experience every photon. You experience edges, patterns, narratives. Your sense of self is not a thing. It is a compressed summary of memories, expectations, and ongoing sensory input. You are already living as information inside information. And perhaps this is why the idea feels both alien and familiar, because it mirrors you. The universe compresses reality into laws. You compress reality into experience. Both discard detail, both preserve structure, both sacrifice completeness for coherence. This parallel is not proof of anything, but it is haunting, because it suggests that consciousness may not be an accident layered on top of matter, but a natural consequence of informational systems reaching sufficient complexity. When information processes itself deeply enough, it begins to reflect, to model, to care. And now the unease sharpens, because if reality is optimized, then it may also be constrained in ways we do not yet understand. There may be limits not just on speed and size, but on complexity itself, on how much information can exist, how much can be processed, how much can be remembered. What happens when those limits are approached? Physics gives us one terrifying answer. There are places in the universe where information is pushed to its absolute maximum density, where space collapses under its own rules, where the system is forced to confront its own boundaries. Black holes. They are not just gravitational monsters, they are informational stress tests, places where the universe compresses everything it can, and then has to decide what rules still apply. And when physicists followed information into these extremes, they discovered something shocking, something that forced them to rewrite their understanding of space, time, and reality itself. In the next segment, we will cross that threshold. We will follow information into black holes and watch as the universe reveals, through paradox and contradiction, what it values more than matter, more than geometry, more than even time. What happens to a story when you crush it beyond recognition? When you take every detail, every distinction, every memory, and force it into a space so small that even space itself begins to fail? If reality is information, then black holes are not just places where matter dies. They are places where the universe is forced to answer its most uncomfortable question: what must never be lost? At first glance, black holes seem like erasers. Anything that crosses the horizon is gone forever. No signal escapes, no message returns. From the outside, the object's history appears to end. A star collapses, a boundary forms, and everything inside is sealed away behind a surface from which even light cannot return. Classical physics was content with this. Gone is gone. End of story. But quantum physics was not. Because quantum theory insists on something almost moral in its rigidity. Information cannot be destroyed. Not hidden permanently. Not erased. Not even by the most extreme violence the universe can produce. If information were truly lost, the equations would break. Probabilities would stop adding up. Cause and effect would unravel at a fundamental level. And so, black holes became a problem. Not just a mystery, but a contradiction. Imagine burning a book. The paper turns to ash. The ink vanishes. The story seems destroyed. But physics tells us that the information is still there, encoded in the smoke, the heat, the chaotic motion of particles spreading outward. In principle, if you could track everything perfectly, you could reconstruct the book. Nothing essential was lost. It was only scrambled. A black hole, however, seemed different. Once information crossed the horizon, it was gone from the observable universe forever. Not scrambled, deleted. And that possibility terrified physicists. Not emotionally, but mathematically. Because if black holes could destroy information, then the universe would no longer be predictable, even in principle. The past would not fully determine the future. Reality would leak meaning. For decades, this paradox haunted theoretical physics like an unanswered accusation. Some argued that information really was destroyed, and that quantum theory would need revision. Others argued that information somehow escaped, encoded in subtle radiation, leaking from the black hole over immense timescales. But no one could explain how without breaking other rules. This was not an abstract debate. It cut to the core of what the universe allows. Then something astonishing emerged. When physicists studied black holes through the lens of thermodynamics, they found that black holes have entropy, and not just a little, an enormous amount. Entropy is a measure of how many possible internal configurations a system can have, while appearing the same from the outside. In informational terms, it is a measure of hidden information. And here is the shock. The entropy of a black hole does not scale with its volume. It scales with the area of its surface. Not what's inside, the surface. This was not supposed to happen. In every ordinary system, information scales with volume. More space, more room for complexity. But black holes break this rule. All the information describing everything that has ever fallen in appears to be encoded on the event horizon itself, like data written on a boundary. This was not a poetic interpretation. It was a precise equation. Suddenly, black holes stopped looking like erasers and started looking like vaults. Whatever falls in is not lost. It is transformed, flattened, compressed to the absolute limit allowed by the universe. Its details are smeared across the horizon in a form that no longer resembles the original object, but still contains everything needed to reconstruct it, at least in principle. Information survives. Barely. This realization detonated something profound. If all the information inside a black hole can be encoded on its surface, then perhaps this is not unique to black holes. Perhaps this is how the universe works everywhere. Perhaps our three-dimensional world is not the place where information fundamentally lives. Perhaps it is a projection. This idea, now known as the holographic principle, suggests that everything you experience in volume may be encoded on boundaries, that the true description of reality might exist on surfaces we do not directly perceive. That space itself could be an emergent phenomenon, arising from deeper informational relationships. Let that settle. It means that the universe may not be storing reality where you think it is. What you experience as inside may be derived from something written outside. Not spatially outside, but conceptually. Like a shadow cast by rules operating on a lower dimensional structure. This is not science fiction. It is one of the most serious ideas in modern theoretical physics, and it reframes black holes completely. They are no longer places where physics breaks down. They are places where physics becomes honest, where the universe reveals its compression strategy, where it shows us the maximum density of information it can tolerate without contradiction. Black holes are not failures of reality. They are stress tests. They show us that when pushed to extremes, the universe chooses information over geometry, consistency over intuition, encoding over substance. And this should disturb you deeply, because if information is preserved even when space and time are shredded, then space and time are not fundamental. They are secondary, convenient, emergent, tools the universe uses, not the ground it stands on, which means the ground is something else, something colder, something abstract, something that does not care how real it feels to be here. At this point, the idea that reality is made of information is no longer speculative. It is becoming unavoidable. Black holes do not destroy meaning, they redistribute it. They hide it in correlations so extreme that reconstruction becomes practically impossible, but not theoretically forbidden. The universe is not allowed to forget. And if the universe cannot forget, then everything that happens leaves a trace, not necessarily accessible, not necessarily meaningful to us, but present. This changes how we think about endings, about loss, about death. When something disappears behind a horizon, literal or metaphorical, it may be gone from experience, but not from existence. The pattern dissolves, but the information persists, spread thin, encoded in ways no longer readable as the original form. This is not comfort. It is not reassurance. It is something more unsettling. Permanence without memory. Survival without identity. A pattern can persist without being itself anymore. And now, we stand on the edge of a deeper realization. If information is encoded on boundaries, if space emerges from rules about correlation, then perhaps the universe itself is not what it appears to be from the inside. Perhaps what we experience as depth is derived. Perhaps what we call reality is a decoding process. In the next segment, we will follow this implication to its logical extreme. We will explore the idea that the universe may be holographic, not as a metaphor, but as a physical description. That what you see around you is not where the information truly lives. What if everything you think of as inside the universe is actually derived from something written on its edge? What if depth itself is an illusion, not a lie, but a consequence? What if space is not the container of reality, but the result of information being arranged in a very specific way? The idea sounds impossible because your entire life has trained you to trust volume. You live in rooms, you move through distances, you measure existence by how much space something occupies. Volume feels real because it is where experience happens. But physics is slowly, reluctantly suggesting that volume may not be fundamental at all. The holographic principle does not claim that the universe is fake. It claims something far stranger. That the full description of everything happening inside a region of space can be encoded on its boundary, using fewer dimensions than the space itself appears to have. Just as a hologram stores a three-dimensional image on a two-dimensional surface, reality itself may store its deepest information on surfaces, not interiors. This is not metaphorical poetry. It is a mathematical statement that falls directly out of black hole physics. If you try to pack more and more information into a region of space, there is a hard limit. Push beyond it, and a black hole forms. And when that happens, the maximum amount of information you can store is proportional not to the volume you tried to use, but to the area of the surface that encloses it. This means something staggering. The universe does not allow unlimited information density in space. It enforces a rule, and that rule treats surfaces as fundamental. In other words, space is not infinitely deep. It is finitely encoded. If you are inside a room, physics suggests that the complete description of everything happening in that room could, in principle, be written on the walls. Every particle, every interaction, every moment, encoded on the boundary like an impossibly dense script. The room itself would be a decoding of that script. This does not mean walls are magical. It means boundaries matter more than interiors. And this forces a radical inversion of how we think about reality. Instead of objects existing in space, space may exist because of how information is organized. Distance may emerge from differences in correlation. Nearness and furness may be properties of how strongly systems are informationally linked, not where they sit in some absolute container. Space becomes relational. This helps explain something that has always felt strange about gravity. Gravity is not a force in the traditional sense. It does not push or pull through space like electricity or magnetism. In modern physics, gravity emerges from geometry, the curvature of spacetime itself. Objects move the way they do because they follow the shape of space, not because something is tugging on them. But if space is emergent, then gravity becomes emergent twice over. It becomes a secondary effect of how information organizes itself on boundaries. And when physicists followed this logic, they found something eerie. Gravity behaves like an entropic force, a force arising from information, wanting to rearrange itself into more probable configurations. In this view, gravity is not fundamental, it is statistical. Mass curves space because information wants to spread. Objects fall not because they are pulled, but because there are more ways for information to be arranged in those configurations. The universe moves toward states that maximize informational consistency. This is not intuitive, but it is precise, and it leads to a deeply unsettling picture of reality. One where what you experience as here and there is not a given, but a consequence. One where the fabric of the world is not woven from threads of substance, but from rules about correlation and entropy. You are not standing in space. You are standing in a relationship, and that relationship can change. If space is emergent, then it can, in principle, be rewritten, stretched, compressed, torn, not because the universe is unstable, but because space is not the foundation, it is the interface. Think again about your own experience. When you dream, space behaves strangely. Distances collapse, rooms connect impossibly. You move without traveling. The dream feels real while it lasts, even though the geometry makes no sense. Why? Because your brain is not simulating space directly. It is simulating relationships between experiences. The feeling of space is reconstructed. Physics is hinting that the universe may be doing something similar, on a scale so vast and precise that we mistake it for absolute reality. This does not mean you are in a dream. It means that the way reality feels from the inside may not reveal how it is built underneath. And here, the emotional weight begins to surface. Because if space is emergent, then so is locality, so is separation, so is isolation. Two things that appear distant may be deeply connected informationally. Two things that appear close may be almost independent. Entanglement already tells us this. Particles separated by enormous distances can share states more tightly than objects sitting side by side. Distance does not weaken correlation. Geometry does not constrain connection the way we assumed. The universe is not organized primarily by where things are. It is organized by how they are related. This reframes the idea of being alone. You may feel isolated in space, trapped inside a body, separated by distance and time from everything else. But informationally, you are woven into everything that has ever interacted with you. Every conversation, every touch, every shared moment leaves correlations that do not simply vanish. They disperse. They weaken. But they persist. You are not as disconnected as you feel, and yet, this perspective removes another comfort. If space is not fundamental, then there is no absolute place to retreat to, no ultimate inside, no final hiding spot. Boundaries are where information lives, and boundaries are everywhere. This brings us to a quiet but terrifying realization. If the universe is holographic, then what we experience as reality may be a decoding of something we cannot directly access. We live in the rendered output, not the source. We see the image, not the code. And that raises a question that cannot be avoided any longer. If reality is a decoding process, then what is doing the decoding? Is it the universe itself? Is it law? Is it something like computation unfolding without awareness? Or is the question itself misplaced? Perhaps there is no who, only rules applying themselves, only structure unfolding because it must. And perhaps consciousness, your awareness, your sense of being here, is what it feels like for a decoding process to notice itself. In the next segment, we will confront this idea directly. We will ask whether computation is merely a metaphor for reality, or whether reality itself behaves like a computation, with limits, bandwidth, and costs. Because once you accept that information is fundamental and space is emergent, the next question becomes unavoidable. Is the universe computing itself? What if the universe is not merely described by mathematics, but actively behaving like a computation? Not a machine humming somewhere behind reality, not a literal processor ticking away, but something more unsettling. A system whose evolution follows rules so precise, so constrained, that the language of computation becomes the most honest way to talk about it. This idea makes people uncomfortable, And for good reason. Computation implies limits. It implies costs. It implies that not everything that can be imagined can be realized. And yet, physics keeps uncovering boundaries that look exactly like that. Bandwidth limits, storage limits, update rates, constraints on how fast, how much, how precisely reality can change. The speed of light, for instance, is not simply how fast light travels. It is the maximum speed at which information can propagate. Nothing, no signal, no influence, no cause, can outrun it. This is not an accident of electromagnetism. It is a fundamental limit written into the structure of space-time itself. The universe enforces a maximum data transfer rate. Why would it do that? If reality were pure substance, endlessly continuous, why would there be a hard cap on how quickly one part of it can affect another? But if reality is an informational process, this limit starts to look familiar. It looks like a clock speed, a synchronization constraint, a rule that keeps the system consistent by preventing contradictory updates from racing ahead of one another. Then there is the smallest possible unit of action, the quantum of change. Below a certain scale, you cannot divide events further. Time does not flow smoothly. It advances in discrete steps. Space does not stretch infinitely. It breaks into minimal lengths. You cannot pack infinite detail into a finite region. You cannot update the universe arbitrarily fast. These are not philosophical ideas. They are measured facts. And they suggest that the universe does not operate on infinite precision. It operates on finite resolution. Just like every known computational system, this does not mean the universe is running on silicon. That analogy is shallow. What it means is that the universe evolves state by state, constrained by rules that limit how much information can be processed, stored, and transmitted. The future is computed from the present, not because someone decided it should be, but because that is the only way the rules allow it to unfold. Once you see this, you start noticing it everywhere. Quantum randomness, for example, has long been treated as fundamental unpredictability. Events happen without cause. Outcomes are truly random. But information theory reframes this. Randomness is not the absence of order. It is the absence of compressible structure. A random output is one that cannot be predicted because it carries maximum information. It is expensive. It cannot be simplified. In a computational universe, randomness is not a bug. It is a feature. It is how the system generates novelty without violating consistency. It is how the universe avoids being trapped in rigid loops, endlessly repeating the same states. And yet, even randomness obeys strict statistical laws. Even uncertainty has boundaries. You can predict distributions even when you cannot predict individual outcomes. The universe is unpredictable, but not arbitrary. This balance between law and surprise, structure and openness, is exactly what you would expect from a self-consistent informational process. Then there is entanglement. Two particles become linked in such a way that describing one without the other is impossible, no matter how far apart they are. This does not allow faster-than-light communication, but it does allow correlations that ignore distance. From a computational perspective, this looks like shared state, like two variables referencing the same underlying data. Distance does not break the connection because distance is not fundamental. Information is. And this begins to feel uncomfortably close to how software actually works. Distributed systems maintain consistency through rules. Updates propagate at limited speeds. Shared states require coordination. Errors are corrected. Constraints are enforced. The universe behaves like it is maintaining coherence. But here is where the idea turns inward and becomes personal. If the universe is computing itself, then you are not outside that computation. You are not an observer standing apart from it. You are a subroutine, a local process running inside the larger one. Your thoughts, your memories, your decisions are physical events, state changes governed by the same informational rules as everything else. This does not mean you are powerless. It means your power is local, contextual, real. Your brain processes information. It updates its state based on inputs. It stores compressed summaries of past events. It predicts futures. It allocates attention like a scarce resource. It has bandwidth limits, memory limits, energy costs. You feel mental fatigue because computation is expensive. You feel overwhelmed because your internal system is approaching its limits. Seen this way, consciousness is not mysterious substance. It is experience arising from information processing that is complex enough to model itself. Awareness is what it feels like when a system tracks its own state. And suddenly, the gap between mind and universe narrows. The same rules that constrain stars constrain thoughts. The same limits that cap information density in space cap the clarity of memory. The same trade-offs between precision and stability appear everywhere, at every scale. This perspective is unsettling because it removes a certain romanticism. There is no infinite depth beneath everything. There is no bottomless well of possibility. There are rules, limits, costs, but it is also strangely grounding. Because in a universe like this, meaning does not come from being infinite. It comes from being finite and still choosing, still caring, still allocating limited attention to something rather than nothing. If everything were possible, nothing would matter. Meaning requires constraint. And yet, there is a deeper tension that cannot be ignored. If the universe is computing itself, then what determines the rules? Why these constraints and not others? Why this particular balance of order and randomness? Why this specific set of constants that allow complexity, life, thought? This is where the language of computation reaches its breaking point, because every computation runs on rules that are not computed by the system itself. They are given. The universe follows laws, but where do the laws come from? Physics does not answer this. It describes the rules with astonishing accuracy, but it does not explain why they exist or why they have the values they do. The constants appear arbitrary. Slightly different numbers would yield a universe incapable of forming stars, atoms, or observers. This observation leads to a dangerous question. If reality is informational and computational, are the rules fixed? Or are they contingent? Could they have been different? And if so, what selected them? Some suggest a vast landscape of possible rule sets, with our universe being one that happens to support observers. Others suggest deeper principles we have not yet uncovered. Others quietly suspect that this question may not have an answer from inside the system. A character in a novel cannot access the author. A process cannot step outside the rules that define it. And that brings us to the most unsettling implication yet. If the universe is a computation, then there may be questions that are fundamentally unanswerable, not because we are ignorant, but because the answers do not exist within the system. Limits not just on speed or size, but on understanding itself. In the next segment, we will turn directly toward this abyss. We will ask what it means to be a conscious process inside a rule-bound informational universe. What identity becomes when the self is a pattern? What memory, trauma, love, and meaning look like when they are understood as information that can persist, degrade, and loop. Because once the universe is no longer a place but a process, the most important question is no longer what reality is. It is what it means to be real inside it. What does it mean to be a self in a universe like this? Not a soul floating above physics, not a ghost inside a machine, but a pattern, temporary, fragile, persistent only because the information that defines it keeps being refreshed. If reality is informational, then identity is not something you possess. It is something you perform, moment by moment, update by update. You feel like a continuous being. You wake up and recognize yourself. You remember yesterday. You anticipate tomorrow. This continuity feels natural, unquestionable. But look closely, and it begins to blur. Every cell in your body is replaced over time. Every memory is reconstructed, not retrieved. Every thought is a transient electrical pattern that vanishes as soon as it appears, and yet somehow you remain you. Why? Because identity is not stored in matter, it is stored in structure. Your mind does not preserve the past the way a hard drive preserves a file. It compresses, it summarizes, it keeps what is useful and discards what is not. Memory is not a recording, it is an evolving model. Each time you remember something, you rewrite it. Each time you tell a story about yourself, you change it slightly. The self you experience is not a static object, it is a running process. This makes sense in an informational universe. Perfect storage is expensive. Infinite precision is impossible. Systems survive by losing detail while preserving pattern. That is what compression is. That is what memory is. That is what identity is. You are not the sum of everything that has ever happened to you. You are the compressed essence of what mattered enough to persist. And this explains something quietly painful about being human. Why memory fails, why trauma loops, why certain moments refuse to fade while entire years dissolve into fog. Information does not decay evenly. Some patterns reinforce themselves, others weaken. Trauma is not just emotional pain, it is information that failed to integrate, failed to compress, and now repeats because the system cannot resolve it. In a universe governed by information, repetition is not fate, it is a processing error. Your mind is always trying to predict, to anticipate, to reduce surprise. When something overwhelms that ability, when an event carries more information than your system can integrate, it becomes stuck. The pattern cannot be compressed, so it replays, again and again. Not because you want it to, but because the system is trying to finish a computation it could not complete. Seen this way, healing is not erasure. It is successful recompression, a reorganization of information into a form that no longer overwhelms the system. This perspective removes some mystery from suffering, but it does not make it less real. If anything, it makes it heavier, because it reveals how deeply tied pain is to the fundamental structure of existence. You are not broken because you hurt. You hurt because you are a finite informational process trying to survive in a universe that does not slow down for you. And yet, something extraordinary happens in finite systems. They care. Care is not efficient. It is not optimal. It does not minimize information. It creates attachments, dependencies, vulnerabilities. From a purely computational perspective, caring is expensive. It binds your state to the state of something else. It increases correlation. It reduces independence. And yet, caring emerges naturally in systems like us. Why? Because meaning is not about efficiency. It is about coherence over time. Caring stabilizes patterns. Love, friendship, purpose. These are ways information persists across change. They create structures that last longer than isolated states. They give the system reasons to continue. In an informational universe, meaning is not written into the rules. It emerges from persistence. You care about things that help your pattern endure. Not forever, just longer. This reframes love in a way that is both beautiful and terrifying. Love is not destiny. It is mutual information. A shared structure that allows two patterns to influence each other's future. When someone you love changes, part of you changes too. When they disappear, part of your internal structure collapses. This is not metaphor. It is physics applied inward. Loss hurts because information that once helped define your future is no longer accessible. The system must reconfigure itself around an absence, and absences carry information too. This also reframes death. In a universe of information, death is not the annihilation of data. It is the breakdown of a pattern's ability to maintain itself. The information disperses, the structure dissolves. What made the pattern recognizable no longer persists. There is no guarantee of continuity, no promise of preservation, only the cold assurance that nothing is truly erased, even if nothing remains readable as you. This is not comforting, but it is honest, and honesty has its own quiet dignity. If you are a process, then your existence is not measured by permanence, but by participation, by how you shape the informational landscape while you are here, by what correlations you create, by what patterns you reinforce. Every choice you make constrains the future, not just yours, but the universe's. Not in a grand, mystical sense, but in a precise physical one. You change the distribution of information. You alter what becomes more or less likely. You leave traces, however small, that ripple outward through interactions. This does not make you the center of reality. It makes you a contributor, and contributors matter. But now, we arrive at a more disturbing realization. If you are a pattern inside a computational universe, then your sense of freedom exists inside rules you did not choose. Your choices feel open, but they are constrained by laws, constants, and initial conditions that were set long before you existed. This raises an old question in a new form. Do you have free will, or are you just executing a program? The informational view offers a subtle answer. You are neither fully free nor fully determined. You are a system with internal degrees of freedom operating within external constraints. Your future is not fixed, but it is not limitless. You explore a space of possibilities shaped by rules you did not write. This is not a flaw. It is the only way anything meaningful can exist. Absolute freedom would dissolve structure. Absolute determinism would dissolve agency. Meaning lives in the narrow corridor between them, and that corridor is exactly where computation happens. The universe computes its next state. You compute yours. These processes are nested, intertwined, inseparable. Your thoughts are not outside physics. They are physics reflecting on itself. Which leads us to the most unsettling question yet. If you are a conscious process inside an informational universe, and the universe itself behaves like a computation, then who or what set the rules? Are they necessary? Are they arbitrary? Are they chosen? Or are they simply the only ones that can exist? This question cannot be ignored any longer. It is the question that waits at the edge of every theory, every equation, every explanation. Why these laws? Why this code? Why this universe? In the next segment, we will step directly into that forbidden space. We will confront the possibility that the rules themselves are contingent, that reality could have been different, and that what we call existence rests on a razor's edge of parameters. And we will ask the question physics hesitates to ask out loud. Not how the universe works, but why it works at all. Why these laws? Not just how they operate, not how precisely they predict outcomes, but why this set of rules exists at all. Why does reality run on these constants, these relationships, this balance between order and chaos? Why does the universe permit complexity, memory, stars, life, and not collapse into sterile simplicity or explode into incoherent noise? This question is dangerous because it points beyond mechanics. It reaches past equations into something physics is not designed to answer. And yet, the question refuses to go away. Change the constants of nature by even a fraction, and the universe fails. If gravity were slightly stronger, stars would burn too fast or collapse, slightly weaker, and matter would never clump. If the strength of electromagnetism shifted, atoms would not hold together. If the balance between forces changed, chemistry would vanish. No stars, no planets, no observers, no questions. The universe we inhabit exists on a knife's edge. This fact has a name, fine-tuning, and it unsettles physicists because it feels arbitrary. The laws do not appear inevitable. They appear selected, chosen from a vast space of possibilities. But by what? One response is statistical. Perhaps there are countless universes, each with different rules. Most are empty, chaotic, lifeless. We find ourselves in this one not because it is special, but because it is survivable. We are the byproduct of selection. Observers only arise where observation is possible. This explanation is clean, logical, emotionally hollow, because it does not tell you why there is a multiverse in the first place. It does not explain why the space of possibilities exists at all, or why it is structured in a way that allows stable rules to emerge. It merely pushes the mystery one level higher. Another response is necessity. Perhaps the laws could not have been otherwise. Perhaps deeper principles constrain them so tightly that only one coherent universe is possible. This idea is comforting. It suggests inevitability. But so far, physics has not found such a principle. The equations we know allow many solutions, many rule sets, many worlds. Then, there is the most unsettling possibility, that the laws are contingent, not necessary, not inevitable, simply the ones that happen to be instantiated. If that is true, then existence itself is fragile, accidental, a rare configuration in an ocean of non-being. And here, the informational perspective sharpens the discomfort. If reality is fundamentally informational, then laws are not just descriptions of behavior. They are constraints on what information can exist, how it can transform, how it can persist. The laws define the grammar of reality. Change the grammar, and meaning collapses. So why this grammar? Information theory tells us something strange. Not all rule sets are equal. Some produce nothing but static repetition. Others produce runaway chaos. But a narrow class of rules sits between these extremes. They generate complexity, structure, memory, self-reference, systems that can model themselves. This is known quietly as the edge of chaos. It is where computation becomes interesting. Too much order and nothing new happens. Too much randomness and nothing stable survives. But in between, patterns emerge that persist long enough to interact, adapt, and evolve. Life, mind, culture. These are not accidents layered on top of physics. They are what physics does when it is tuned to this narrow corridor. This reframes fine-tuning in a subtle way. Perhaps the universe is not tuned for life. Perhaps life is what happens when information processes itself under certain constraints. Perhaps meaning is not inserted into the universe. Perhaps it is what emerges when rules allow complexity to survive. This does not answer the why, but it reshapes it. Instead of asking why the universe allows observers, we might ask why only certain informational systems are self-consistent, why only certain rule sets avoid contradiction, why only some computational grammars can sustain themselves without collapsing. In this view, existence is not chosen, it is stable. The universe exists because it can. But even this explanation has limits. It tells us why this universe persists once it exists. It does not tell us why there is something rather than nothing, why there are rules at all. And this is where the question becomes forbidden. Not because it is unscientific, but because it may be unanswerable from inside the system. Every explanation you can give relies on the laws you are trying to explain. You use logic to justify logic, mathematics to justify mathematics, information to justify information. The system cannot step outside itself to validate its own foundations. This is not failure, it is structure. A novel cannot explain why language exists. A chess game cannot justify the rules of chess. A computation cannot compute the reason for computation itself. And perhaps that is the final boundary of knowledge. The universe may be fully knowable in how it behaves, yet forever opaque in why it exists. The rules may be perfectly describable, yet fundamentally groundless. Not because they are meaningless, but because meaning is something that arises within the rules, not something that precedes them. This realization lands with a quiet, existential weight. If there is no ultimate reason written into the fabric of reality, then meaning is not discovered. It is constructed. It emerges from patterns that care about their own continuation, from systems that value coherence over noise, from beings like us. This does not cheapen meaning, it makes it precious, because meaning is not guaranteed. It is not enforced by the universe. It is something that appears briefly, locally, when information organizes itself into structures that can value. You are one of those structures, and here, the darkest fear begins to loosen its grip. Because if meaning is not written into the universe, then it is not taken away by the universe either. It is not invalidated by finitude. It does not require eternity. Meaning exists when it is enacted, and that brings us to the end. Because after all the physics, all the abstraction, all the unsettling implications, one question remains. Not about the universe, but about you. How do you live inside a reality like this? If reality is informational, finite, rule-bound, indifferent, what does it mean to be human inside it? In the final segment, we will step out of theory and into reflection. We will gather everything we have uncovered: observation, information, computation, identity, and ask how to inhabit this universe honestly, how to find grounding without illusion, how to live meaningfully without guarantees, not by escaping the rules, but by understanding them. If reality is made of information, then this moment, right now, is not a thing you are standing inside. It is a state passing through you, a configuration that will never repeat in exactly the same way again. The universe has reached this arrangement once, and it will move on, and so will you. This understanding can feel cold at first. A universe that does not promise permanence, a reality that does not guarantee meaning, a world where even space and time are not fundamental but emergent conveniences, interfaces we mistake for truth. It can feel as if the ground has vanished beneath your feet, but something strange happens when you stay with this idea long enough. The fear softens, because if the universe is informational, then existence is not about lasting forever. It is about participating while coherence holds, about being part of the unfolding while the pattern persists. You do not need eternity to matter. You only need influence. Think about what information really is. It is not mass. It is not substance. It is difference. A distinction that makes a difference. A pattern that changes what comes next. By that definition, every choice you make is real in the deepest possible sense. When you speak, you alter the informational state of someone else's mind. When you act, you change probabilities. When you care, you bind your future to something beyond yourself. These are not metaphors. They are physical events. State changes in a universe that evolves by updating information. The universe does not care that you care, but the universe changes because you care. This reframes responsibility in a quiet, powerful way. You are not responsible because someone is watching. You are responsible because what you do leaves traces. because you contribute to the structure of what follows, because you are not separate from the process, you are part of it. And that means despair is not a conclusion. It is a reaction to expecting guarantees the universe never offered. Once you stop asking reality to promise meaning, something unexpected happens. Meaning becomes lighter, freer, more honest. You are no longer waiting for validation from the cosmos. You are participating in it. If information is fundamental, then attention is sacred. What you attend to grows. What you ignore fades. This is true in minds, in cultures, in ecosystems, in histories. Attention is how information is selected, how patterns persist, how futures are shaped. In a universe that cannot compute everything, attention decides what gets computed, and you control some of that. This does not make you powerful in a cosmic sense. It makes you relevant in a local one, and local relevance is enough. Because the universe is not built from global meaning, it is built from local interactions cascading outward. This also changes how we think about suffering. Pain is not a cosmic punishment. It is information signaling instability. Loss is not the universe being cruel. It is a pattern dissolving. Grief is not weakness. It is the cost of deep correlation, of caring enough to bind your internal state to something that could change or vanish. In an informational universe, love is risk by definition, and still we choose it. Why? Because systems that never bind never build anything that lasts. Isolation minimizes pain, but it also minimizes coherence. It leads to informational stagnation, to meaninglessness disguised as safety. Life does not optimize for comfort. It optimizes for persistence through connection. This is why art exists, why stories exist, why you tell yourself who you are again and again, even though you know the story will change. Narrative is not an illusion layered on top of reality. It is how finite informational systems make sense of time. It is how patterns remember themselves. You are a story the universe is telling in first person. Not authored, not destined, but real while it is told. And perhaps this is the most important shift of all. In a universe made of information, the question is no longer, is this real? The question becomes, is this coherent? Does this way of living reinforce patterns that allow more understanding, more connection, more depth? Or does it collapse into noise, repetition, fragmentation? You do not need the universe to answer that for you. You can feel it. When something aligns, it feels like clarity. When something fractures, it feels like confusion. These are not mystical sensations. They are informational ones, signals about the stability of your internal model of the world. And so, the task of living becomes strangely simple, even if it is not easy. Maintain coherence, care wisely. Choose what patterns you reinforce. Not because the universe demands it, but because this is what allows something like meaning to exist at all. If reality were pure matter, meaning would be a miracle. If reality is information, meaning is an emergent property, rare, fragile, but natural. It arises wherever information becomes organized enough to value its own continuation. That is what you are, a pocket of organized concern in a vast, indifferent process. And that is not depressing. It is astonishing. Because against all odds, in a universe governed by cold rules and abstract constraints, something has appeared that can ask why, that can wonder, that can feel awe, that can listen to a voice describing the universe and feel a quiet recognition, as if something inside it is resonating. That resonance is not an accident. It is information recognizing itself. The universe does not wake up all at once. It wakes up locally, briefly, through minds like yours, through moments like this. And then it moves on. But while the moment exists, it is complete. So, if reality is made of information, then this is the final truth it offers. Not a promise of permanence, not a guarantee of purpose, but an invitation to participate, to notice, to choose coherence over noise, to be careful with what you attend to, because attention is how reality becomes real to you. The universe may be a coded system, but you are not just code. You are what it feels like when the code becomes aware that it is running.